something you may be familiar with is that IEX has a bunch of helpers built into it. So you have an H helper that gives documentation and an open helper, which will take you directly to source code. The T helper returns types. The B helper returns behaviors that are defined in a given module. But one thing that I found that I kept doing is that I would open IEX explicitly to go into one of these helpers. And so I wrote a tool, which I've been calling Exhelp, but Exhelp is easier to say, which brings these helpers to the command line. So I can run Exhelp enum. And importantly, like the documentation for this kind of scrolls past the bottom of the screen. Now my terminal lets me scroll back, but if I hit spacebar or any other key, I touch my keyboard, I'm just snapped back down to the bottom and I can't remember where I was in the documentation. But because I'm now putting it to standard out, I can pipe it into a pager and control it however I want to do it. So I can scroll up, I can scroll down, I can use Less's search function, highlight all the instances of enum in enum's documentation. Hopefully there's some of those, so on and so forth. And I took this and kind of did it for each of the major helpers that I could find. So there is, that's for documentation, which works just as well for specific functions. So I can pull up the documentation for a specific function. If I have the Erlang documentation installed, I can pull up Erlang documentation and read it the same way. You have to have that compiled specifically, but as long as you have it compiled on your system, Exhelp is able to find it. Exhelp has an open flag, which takes a module or a function. So I can put in enum.map and open directly to the line. It's hidden under my Zoom controls, but line 1590 in the lib elixir lib enum.ex file, showing exactly where it's defined. We can see things like when you're mapping over a list, it'll just call out to lists.map instead of actually doing anything exciting. We can even open, I have a -o for simplicity. We can actually go to lists.map and open up an Erlang function. In the same way, opens directly to the line 1242 hidden under my Zoom controls in the Erlang file that implements map, which has led to some questions from some people in the audience before. There's the type helpers there, so I can look at the types defined in enum. I can look at the behaviors defined in, we'll use Erlang's gen server. It also has behaviors defined in it too. But I added some new features. So in IEX, you have tab completion. I have not yet found a way to do tab completion using an Elixir script or an E script, an Erlang script, because it is technically a script. So maybe there's a way to do bash completion, but instead I added a search function. So I can do --search or -s to start looking for a module. So I can look for all modules that begin with capital ENU, and it'll just list them all out. Similarly, I can look for all functions in enum that begin with the letter M. And this works just as well for Erlang functions. So I can look for all functions in lists that begin with an M. But the problem with this is that it only works for starts with. So you may want to do a more advanced search on the functions in a module or the modules that are in your project. So I added this -- all modules flag, which will just list out every single module that Exhelp can get its hands on. But importantly, we can pass that into grep and look at all modules that have eco in them. So we have record and Exhelp, decompose, so on and so forth. And similarly, I have an all functions flag, and we can use, we can see what functions have an arity of 11 or 111, if such a function exists. And there's two: one calendar ISO date time to string, and dets v9 initiate file. And I'll spoil some of the fun. There's nothing particularly interesting about dets v9. It's just the version 9 internal implementation of dets. There's no v8 or v7 in the Elixir source code to be found, which is a bit unfortunate. So that's the main features of Exhelp. But I added one more feature, which I think is kind of the killer feature for this, which is that it has mix support. So if I add -x mix like you would for IEX, then I can do a search on modules in my project or in my dependencies. So this is a Ziegler project, just kind of toying around and playing with Ziegler. And if I run exh-x mix and start looking for all modules that begin with capital ZI, I can actually find that there's a module in Zig called zig.doc.parser. And now that I know that that exists, I can run --open on zig.doc.parser and open directly into that module, hopefully, and see how it's implemented, what's going on in here. Apparently it handles the parsing of Zig code for documentation purposes, right? So, and similarly, I can look at documentation directly. So I can pull up the documentation for Zig. It takes a bit longer. Helps if I actually add the mix flag and don't just go directly into the module. The mix does take a bit longer just because it is starting up the project and making sure that mix is running. But now I can read the documentation for Zig that I already have downloaded because my project has it downloaded as a dependency, and read through the documentation without tabbing out to a browser, without resorting to another tool. I am a Linux user, so I don't have access to Dash, for example. And Zeal doesn't let you download documentation directly for modules. It only works for the standard library. Turns out I have pretty easy access to most of the documentation in the standard library that is less helpful than it could be. But with this, I was able to explore like Witchcraft, for example, is a Elixir library that implements a lot of Haskell operators into Elixir for functional programming and shenanigans in that direction. And I was able to use the search functionality, just list out all of the Witchcraft submodules of apply and monad and lift, etc., and just start opening them up and reading them without any issues. So that's the tool. And I'll link to the tool at the end of the talk. I'm going to pause here because I see a bunch of messages in chat that I can't see because I'm in the middle of the presentation.
It's all idle banter.
Okay.
You'll regret looking at it.
So
blame Paul.
It's totally Olympic banter, and it's all in support of you, and we're always going to be taking the piss.
Okay, go for it. In any case, I'm going to dig into some of the source code, some of those rough edges that I found in the process of putting this together. So there's one thing that I could have done, but I was unable to do. So IEX helpers .open is the exact open that shows up when I run open. So it's a macro, which is how it's able to handle that like module.function/arity without giving you a division error, is it uses a macro to kind of pass the whole thing as a unit into this decompose and then into open. So the more interesting function to look at is introspection.open/1, which is really the implementation of it. So in this, there's a lot of details, but the two things that it's looking to do is find the file that your source code is in and find the line number that your source code is on. So we'll look, I'll scroll past the details. I have another talk if you're interested in the gory details of how all this is put together. But the interesting point for Exhelp is this application.apter. So it turns out that when you compile an escript, it is a script. So let's pause for a second. Let's make sure we're all on the same page of what in the world an escript is. So an escript is an Erlang script. So it's a compiled script that uses Beam code directly in a script file. If you're interested in creating one out of one of your projects, then you give it a keyword list that tells it a main module, which tells it where to look, and everything else is kind of optional extras. In that module, it will look for a main/1 function, which will pass the arguments from the command line to that main function as a list of strings, and then execute it. And if you add this escript flag to the keyword list in project, you can run mix escript.build or mix escript.install. Build will put it in your local folder. Install will put it into the system path for escript so that you can execute it. In my case, I use ASDF as a version manager for my Elixir and Erlang. So if I do which, it's in my shims folder. And then that shim is looking at a particular location. But I think the best way of showing off what exactly an escript is to just open one up in an editor. So it's literally just like binary Beam code directly in like a banged script. What I find interesting is if you scroll all the way down to the bottom, this is a dev form. So we have some like dialyzer warnings and other things in here. But it's got atoms just like kind of sprinkled in the middle of all this gobbledygook, which is giving a lot of beeping errors in my text editor because it's trying to render them faithfully, despite the fact that them not being actual characters. And this really kind of gives an idea of why we're going to run into some of the issues that I'm about to highlight. So coming back to that open, if we go to rewrite source, which was that function that calls application.apter, the problem is that an escript is an Erlang script. It doesn't know anything about Elixir. In fact, escripts in Elixir are almost kind of like a hack in that because we're compiling to the Beam, Erlang doesn't care because it's already in a Beam file and Erlang knows how to run Beam files. But it's kind of unknowledgeable. So if you run this application.apter from inside of a compiled escript, then it will fail. It'll throw an error saying, no, I'm unable to find that. Ordinarily, if we run this in IEX, application.apter on, say, Elixir, it will give me the file exactly where Elixir, like the Elixir application source files are on my computer. But the escript kind of breaks that. So what I had to do is vendor my copy of open so as to change a private function, because unfortunately rewrite script is a private function. So I replaced that application.apter with this escript dir hack, and it is very much a hack. What I ended up having to do, this ended up being the best solution that I could find, is I used system.command to call out to the system's Elixir installation running -e to tell me what the application.apter is for a specific application that it's looking for. I know you have Elixir installed because you use mix to install this escript. So I can kind of somewhat rely on that being on the system. Also, you probably don't care too much about knowing what Elixir documentation is if you don't have Elixir installed in your system. So I'm relatively confident about that. What's interesting is this default path where it doesn't use that application.apter that we saw before works. And so if I had put in open unaltered, it would have successfully opened Erlang source files and then failed for any Elixir modules that you tried to open, which I thought was hilarious. And that's because an Erlang script expects there to be an Erlang installation on the system. And so it kind of already shells out to the system installation of Erlang, but it doesn't know about the system installation of Elixir. And so it has some trouble. Now, I was a bit naive. I assumed that fixing this line would actually fix all of my problems. Unfortunately, it does allow me to successfully get the file name I need, but there's a second place where that file name is important, which is here. So this open abstract code is actually finding the Beam source file and then opening it up using this beamlib.chunks function, loading in the abstract code into memory, and then it uses some parsing to find line numbers directly from the abstract code. Now, what was happening is the same issue just moved over slightly. is that when you compile an escript, it technically puts, as far as Erlang is concerned, all of those modules are technically in a folder inside of the escript. That folder doesn't exist because the escript is literally just a giant pile of Beam code in a single text file. But Elixir thinks that it exists and goes, hey, beamlib.chunks, here's the Beam file that you want. And then beamlib tries to go looking for that file, and it goes, what the hell? There is no file here. I can't open anything. And so what I had to do is the same workaround of using code.which, which is normally what's in that spot where the escript with which hack is, to ask the system version of Elixir where is the enum Beam file, so that I can get the line number out appropriately. There's some other extra stuff up here, which I will come back to, because those are other fun workarounds. So those are some of the limitations that escripts put on me. One of the other limitations was around search. So there is no search helper in Elixir, because tab completion does that work for you. You don't need a fancy search function most of the time. And so I had to write this myself. One of the issues I had was around finding all of the modules. So there's this cool function called code.allLoaded that returns all of the loaded modules in a list of atoms. Unfortunately, it only returns the loaded ones as per the name. And so, for example, record, which I don't use anywhere in my Exhelp project, I'm sorry for any record fans in the audience, wouldn't show up on a search starting with capital RE, for example. And maybe I want to read about the documentation or any of the submodules of records. So that was a bit of a problem. And so I looked at iex.autocomplete, which is a module that implements the autocomplete logic for IEX, and figured out what they were doing. And they have this extra function that they use this all loaded as well, and then get modules from applications, and then they have to deduplicate them. This get modules from applications function first gets all of the loaded applications and then runs through all of them in a list comprehension using application.getKey, pulling out the modules for each one. The interesting bit is, how do you get the loaded applications? So there is a function you can call, which is like application.loaded applications, for example, which returns a set of tuples that contain the information that we want. However, I copied this function verbatim with the comment that it had in IEX autocomplete. If you invoke application loaded applications, it can still error because we don't call safe fix table beforehand. Since in both cases, we're reaching over the application controller internals, we choose to match for performance. And so instead of using the application.loaded applications, it's doing an ets match on the AC tab, which is the applications table. And per my warning, it has been 10 minutes and I haven't gotten any questions, so my headset died. This is a match specification. So this is a way of specifically finding things in kind of a compiled way using ets. It's my understanding that this particular API was never meant to be publicly accessible. And so it's even more unscrutable than the most inscrutable Erlang code. Thankfully, there are some Elixir libraries that wrap these in macros so as to make them like intelligible and human readable. One of which is matcha, M-A-T-C-H-A. And I was shown a fairly extensive demo where if you have a case where you could do a search using pattern matching rather than a normal like enum.map or an enum.filter, it can be orders of magnitude faster, so long as that it adheres to the specific confines of a guard statement. This is essentially creating a fancy guard clause that finds the thing in question using pattern matching. I'm going to pause for a second. Does anyone have any questions at this point?
When you called out to Elixir and figured out where the docs were,
Mhm.
does that work well with ASDF?
Yes.
Because you said it was a system Elixir. Does that just get
So
the ASDF version that's
it will
loaded?
use the ASDF version with a caveat. So that part works fine. However, if you use mix escript.install on your system, it will install it to the version of Elixir that is currently active when you run that installation command. And so if you want to use the escript with other versions of Elixir, you have to reinstall it and reshim it for each and every one of those versions. Once you have reshimmed it, it works fine. I have tested it using like a local tools version, and it swaps back and forth without any issues.
Yeah, cool.
That was a great question though, because I was concerned about that when I was building it.
Also, on the command line, is there any shell interaction that you need to escape? I was surprised the slash worked just fine. Did you run into any characters that required shell escaping?
Not as such. In fact, I'll show you what I'm doing for that. So I'm using string to quoted, which already handles, I think, a lot of that escaping for me. So it correctly turns things into the appropriate atoms and otherwise straight from the string. Obviously, if you try to run it with something malicious, you're going to get the same thing as though you ran a normal shell command with something malicious. But as far as the Elixir is concerned, it handles all of that right here. What's interesting is that I have a wrapper around this, but IEX introspection decompose, which is the function, that's not /1, it's /2, accepts an AST as its argument and returns an abstract syntax tree as its response. That's because this function is meant to be called from inside of a macro, where the macro turns it into an AST to pass to decompose, and then it takes the response value and it's already built an AST and just compiles all that into the macro, as we can see in IEX dot helpers dot open /1. So here, that term, even though it's being unquoted, is still being passed as an AST into decompose. And then the response value is then turned back into this. So in my code, I have to use a couple extra helpers on both sides to get that. And that's mostly just because I wanted to reuse the decompose logic that IEX is using as much as possible. However, for search, I had to vendor my copy of decompose. So I may actually put some extra work to remove those code evaluations on both sides. Just take it so that it directly takes a string, although I don't know that that would work. I think I might still have to have it accept an AST no matter what. But one thing, so decompose takes like a division statement, because technically when you're using that slash, you're telling Elixir to perform division, and it uses the numerator as the function and the denominator as the arity, and correctly decomposes it that way. But if you call it without a module, so one thing you can do in IEX is I can open, for example, without telling it IEX.helpers.open, and it will correctly find which import is bringing open into IEX, and execute it correctly. The way it does that is using this find decompose function down here. And normally it finds an import, looks in context.functions, and then it looks in the macros, and then it looks in find special form. And then in the actual copy, this is my vendored copy, it returns kernel as the default. The problem I ran into is that I wanted my search feature. So if I do exh -s on MA, I want to return all functions across Erlang and Elixir that begin with MA. And what I found was that in this second case where I'm handling that situation, if I put kernel here, then I would load all modules, including kernel, and then recursively call search, and it would call this, it would pattern match on this function again and create an infinite loop. My test case has caught that one on me. And so what I did, like one thing I figured out quickly is that I could subtract out the problematic module, but I still wanted people to be able to search for kernel functions. And so I vendored my copy of decompose so that I can switch it to module not found. If someone decides to implement module not found as an Erlang library into one of their projects, I'm sorry to say that Exhelp will not be able to find their module that is not found. But I can use that as a case where that correctly finds, and then this, even in the kernel case, it will correctly go down to this pattern match on this head of the function and execute for a specific module. The other details that are kind of interesting about Exhelp are the mix support. So one thing, the way I solved the mix support problem is I grepped the Elixir source code recursively to find where -s mix is invoked. And I found the parser that was responsible for it, and it ultimately calls this form code. Unfortunately, it's in a private function. Otherwise, I would have just called that directly. But this get executable is finding the mix application on your system, and then code.require file executes mix and brings it in and starts the application. And this wrapper is just a way of some extra safety. I don't know that I actually need the wrapper, but it was in the original source code. And so I kept it faithfully. One thing that I had to do again is somewhat predictably, I have not compiled mix into my escript. And so I have to find the mix executable somewhere else. And I have to shell out again to find the mix executable. Another thing that I had to do is mix is a bit finicky in that it uses system.argv, which returns the command line arguments that have been passed in. So everything after exh goes into a list of strings in system.argv. I already have these arguments because they were passed directly to main by the escript protocol. But if you don't clear out, which is what this is doing, it's setting argv to an empty list. If you don't clear that out, mix will try to start with whatever is in the command line arguments. And so I got some hilarious errors of like, there is no mix enum.map/2 function. Mix is unable to start. Please try again. Run mix help in order to find all of the mix functions. And so I just set it to an empty list to not trigger that. The other thing I had to do is run mix compile. Mix will always run compilation every time it's started. You get this when you run ix-s mix as well. But because the escript is not a long-running process, it would background the compilation, go, wait a minute, I have no more work to do, and then crash, like saying, hey, my work's done. And then the compilation would stop midway, which was unhelpful. So running system.command on mix compile creates a block to wait for that compilation to finish, because I need that source code in order to correctly get the docs and the other things out from it for the other helpers. The other thing I did, I have an environmental variable that allows you to just have mix support enabled always, so long as there's a mix.axs file in the folder that you're in. One trouble with this that I discovered more recently is that mix imposes a performance penalty in that it takes about an extra second on my old Linux machine to start up mix every time. Waiting half a second to get your results is kind of tolerable. Waiting a second and like 1.8 seconds to get your results every time is less tolerable. So I actually turned this flag off, especially for this presentation. The other thing that I did was I wanted to integrate with the .iex setup. So IEX has a thing where you can put a .exs file in either your home directory or in overriding it in a project directory. to customize the look and feel of your IX. So you can set like the maximum number of list items that get shown when you run inspect on something. You can change the colors that show up. And I wanted to just piggyback off of that because I'm essentially just implementing a lot of those helpers. And so I found the source code in IX that actually loads that .ix file. And what it does is it checks in the local directory and in the home directory, takes the first one that actually is a real file. So if this doesn't exist, the local one doesn't exist, then it'll go to the system one. The system one doesn't exist, it'll just do nothing. And then it'll read that in using code, string decoded. I could probably change this to code.file now, but, and then I evaluate that quoted. A little interesting tidbit is that in IEX, when it does the startup, it doesn't actually use code string decoded or code eval coded. It uses the Erlang Elixir module, the like Elixir compiler module to call the internal version of both of these two functions. And the reason it does that is that IEX, there's a variable called the env, which keeps track of all of the imports and functions and macros that are currently available. And IEX actually keeps a running state of this env variable. And the Elixir version of that function actually returns that environment, the updated environmental variable after it loads in the .iex file. And so it uses that to keep the state up to date. And that is Exhelp or Exhelp. I've been inconsistent how I've called it throughout this talk.
Awesome. Thanks, Rowland. Are you planning on making this available on?
Yes, so this is
publicly?
available on GitHub. I will link it immediately after I stop sharing my screen. And actually, I can just show the link. It's on my GitHub on Rowland Codes Exhelp, github.com/Rowland Codes Exhelp. And I was very thorough in my README. One thing that I will ask is that I want this to be an effective tool, but I expect that there may still be some rough edges. If you find anything sharp and pointy, it is my intention to sand it down. So create an issue or holler at me on email or otherwise to let me know that you have found a broken edge.
For those who don't know, how do you compile the Erlang docs? Because I don't think that's the default, right?
Yeah.
And I've forgotten, by the way.
Yes. So if you're using, we can go digging for it. So if you're using ASDF, ASDF uses something called curl. I'm going to just remember which of these it's in. It's not that one. I think it's plugins. Erlang. Here we are. So is it curl home? Nope. In bin.
You stopped sharing the screen, by the way.
I did. Well, I'm rooting around folders, so let me find the thing in question, and then I will share my screen again. I don't remember where this is, so.
While you're looking, I feel like that should be the default, by the way.
I agree. It does require
sort of
some
weird
extra
that it-
dependencies that Erlang doesn't require, which might be one of the reasons that it doesn't, but I don't know.
I also feel like this is probably a better way to access Erlang documentation than any other way, because the website's terrible.
Okay, here we go.
I find I can't read it.
Yeah.
Maybe it's just
definitely-
because the Elixir one looks too nice, and then going back
No,
is very hard.
I agree on that front. So in ASDF, there's this file. So let me clear my screen because I can't see under the Zoom controls. So in plugins, Erlang curl home, KERL. If you do an ls-a, there can be a .curl-rc file. You may have to create it if it doesn't exist. And you add these 3 flags. You can choose which ones to keep. But if you want the documentation, you do curl build docs, yes. And then there's an option for man pages and HTML docs. And so long as you have the extra requirements for that compilation, and when you compile using ASDF, it will yell at you if you don't have those installed. You will need to cancel the Erlang installation and start it all over from scratch, which is a bit unfortunate. But you can use this set to install the Erlang documentation. And for the Unix lovers in the class, you need gmake, and it has to be called make, which has proven problematic on some of my other computers.
Is the curl-rc the only way to do it? Are those flags you could set as environment variables or something?
I believe if you're compiling it from scratch, then you can use those somehow, but I don't know because I've never done that.
Cool.
And I don't think it's very well documented on the Erlang website, unfortunately.
Yeah, I think that might be worth adding if you haven't already added it to your README. Stick
Okay.
it in there, because it explains why I've never done it.
Cool. Any further questions for Rowland?
Not a question, but a comment. That was really cool. Thanks, Rowland.
Yeah, I did have a question. Would something like bakeware or burrito help be useful than building this as an e-script?
That's a great question. Bakeware, I don't know what bakeware, but I know that Burrito, I believe they do roughly the same thing. Burrito, what it allows you to do is run a CLI or other application on a system that doesn't have Erlang installed. So what an e-script is going, okay, I assume you have Erlang installed, but the Elixir doesn't matter because I've compiled it to Beam code. Burrito is taking that a step further and saying, okay, so long as you can run a binary executable on a specific architecture, then it just bundles like a Burrito all the Erlang stuff that needs to exist into that executable so it can run. In this case, it wouldn't really help anything because I need access to Elixir and Erlang in order to get the documentation, and you'll want to have those installed in order for me to find the documentation. But for a CLI tool in general, not specifically for Exhelp, yes, Burrito can be helpful to distribute an executable to someone that perhaps doesn't have Elixir or Erlang installed on their system.
A question on that. How large are the docs? Could you not just bundle that along with it per the versions that you want to support? And be the Elixir Erlang equivalent of like Dash or something? And like bundle it all in so you don't have to have a dependency on the outside.
Yes, but so you could do that for the standard library, perhaps. But one of the key features for me is the ability to read documentation for Phoenix or Ecto that I've downloaded for one of my projects. That I would have a lot of trouble bundling in directly into the executable in a reliable, sane way.
You'd be hoovering all of Hex in.
While hilarious and definitely something I might try in a different life, I think it's beyond the scope of this particular project. One idea I did have is figuring out how to put mix as a long running process so that I don't incur that startup cost each time, but figuring out how to separate that out for each project and kill it at an appropriate time when you're done using the CLI tool is less reliable than it is with IEX. So I have not yet found a solution to that.
So you just call it every time?
In this case, yes.
And I can't remember, can you publish escripts on Hex? Does that even make sense?
Yes, you can. There is a hex option for mix escript.install, but there's also a GitHub option for mix escript install. So I just deferred to that one for the time being.
Yeah, nice.
And since I don't really have any pretty hex docs, the README covers all the detail that I want. There shouldn't be any reason to be digging around in the internals of escript, hopefully, if I've done my job correctly. So
Probably
I
just
think GitHub is a better way of doing it.
I mean, why not have both? And it's more fundable.
Perhaps I'll have to learn how to set up a hex project in the mix file to correctly have all the information that is needed.
Super cool. I look forward to using it with Erlang installed.